Okay, this screencast is on sequences and series, a review of the topic to complete our collection that we're building on the standard level IB course. Okay, so this all starts with a study of sequences and patterns of numbers, and there are an infinite number of patterns of numbers, but we concentrate on two types, one being arithmetic. And arithmetic sequences are defined as having a common difference. So in the example here, my common difference is equal to minus 2. Now we find our common difference by taking any term and subtracting the term in front. So 4 minus 6, 2 minus 4, and if this is an arithmetic sequence, then each of these will result in the same number, and that number we are calling the common difference. Okay, so an arithmetic sequence is defined as having a common difference. A geometric sequence is our second type, and that is defined as having a common ratio. So if we have a look at a geometric 2, 6, 18, 54, then we'll have a look at taking any term and dividing by. Here we were subtracting, so up here there was subtracting, in that direction, subtracting. Let's make sure we're going that way. Here we're dividing. So we're taking any term and dividing by a term in front, and what we should get, if it's geometric, we will get the same result. So 6 divided by 2, 3. 18 divided by 6, 3. 54 divided by 18, 3. So our common ratio in this case is 3, and that's how we define our arithmetic and geometric sequences. It's really important that we come back to that. That's what underpins all our work here. Common difference, common ratio. We then go and have a look at how to identify, given that we've got a sequence that is arithmetic or geometric, we can now do whole heaps of calculations based on that core understanding. So if we have an arithmetic sequence that begins find the nth term of, let's say we'll just go 5, 8, 11, 14. So we've got a sequence that goes like that. We start with 5 and we're going up by, in this case, we're going up in threes. 8 minus 5, 11 minus 8. So our difference is 3. Our first term is 5. We denote our first term by U1. So U1 is 5. Our difference is 3. And obviously we've identified right at the outset that this is arithmetic. So we can find out, how do we find out our nth term? Well, if our first term, and we start building a little table here, if our first term is equal to 5, our second term is equal to 8, what we're doing is we're adding 3 each time. But if we rather than get away from this specific example, our first term is U1. So first term is U1. Our second term, for any arithmetic sequence, well, we're going to just add D to that, aren't we? And then our third term, we're going to add another D to that, U1 plus D, which is U1 plus 2D. And we pretty quickly get the hang of the fact that we're just going to add D each time, so the nth term is going to be U1 plus, now this number here, and this number here, there's one difference. So it's going to be U1 plus, you got it, n minus 1 times D. So that's the nth term of an arithmetic, and that's our first formula that we work on. These are all in our formula booklet that we use in the exam. Okay, well that's nice. So if we have a look then at the nth term, we need to go back and answer this question. So for this question here, the nth term, which is un, will equal u1, which is 5, plus n minus 1, we don't know what n is, we're defining the nth term, times 3. So un is equal to 5 plus 3n minus 3, which is equal to, did we get that right? 3n minus 3, yep. So writing it in the other way, 3n plus 2 is our un. So we can therefore go from that point and say, find the, once we've got the nth term, we can find the 150th term. And so we go and find the 150th term, so therefore u150, n representing the number of term, the term number, is 3 times 150 plus 2, which is 452. So the 150th term is 452. Okay, let's move on to geometrics. So let's find the, so the question is the nth term of, what were we talking about before? 2, 6, 18, 54, that one there. Common ratio. What's the nth term of it? Right, well we need to go into, what's our first term? Our first term we're going to define, as we did with all sequences, is u1. So our second term, well in a geometric, what are we doing? We're multiplying each term by r, aren't we? u1 times r, or ru1. ru1, u1r, u1r, u1r. So our third term, if we multiply this by another r, is u1r times r, which is u1r squared. And we're going to get to that point again where we recognize there's a pattern here, just multiplying by r each term. So our nth term, if we project to that, is u1 r to the n minus 1, and that's our nth term of a geometric formula. So going to our question up here, where u1 is equal to 2 and our common ratio is equal to 3, then we can say our nth term is equal to 2 times 3 to the n minus 1. So if we want to find the 10th term, this is going to be a job for the calculator. We will go u10 is equal to 2 times 3 to the power of 9. 2 times 3 to the power of 9. So getting our calculator out, 2 times 3 to the power of 9, and getting 39,366. 39,366 is our result. Okay, so that's the nth term of an arithmetic and the nth term of a geometric. How do they look in an exam? We'll have a look at a question from our topic test done at earlier on in the year. And we can see for question 1 here, state whether the sequence is arithmetic or geometric. Well, we'll see here that we're going, oh dear, what happened there? Get rid of that tick. Don't know what that's doing there. Okay, so we can see here, it's a bit thick, that our 12, let's test if it's a, 21 minus, so we've got a common difference of 9, so it's arithmetic. Find the 11th term in the sequence. So for part B, we would say the 11th term is equal to the first term, which is 3, plus 11 minus 1, n minus 1, not n minus 10, n minus 1. Where's my eraser? I've just received an update of this, so all my icons have moved and I can't find it. Hold on. Right, I found my eraser. So 11 minus 1, n minus 1 times the difference, which is 9. So 3 plus 10 times 9, which is 93. That's our 11th term. Let's see if we can find any other questions to do with the nth term. This is a good one. Find x if 3x plus 2, 4x minus 1, and 6x minus 11 are consecutive terms of an arithmetic sequence. We know that 4x minus 1 minus 3x plus 2 has to equal, that subtraction there has to equal d. We're told, remember, that these are an arithmetic sequence. So that has to equal 6x minus 11 minus 4x minus 1. Remember what we said about any term minus the one in front will be equal to d if it's an arithmetic sequence, and we are told that it's arithmetic. So we can solve this. We can solve this problem by solving this equation. So 4x, now it's just algebra, which we all love. 6x minus 11 minus 4x plus 1. Simplifying each side out before we collect. Minus 11 plus 1 is minus 10. So we'll end up with x equaling 8. Okay, let's move on. That's a sum question. That'll come up in our next screencast. I'm up to 11 minutes, so I'm getting close to closing this one. Okay, this is, let's have a look at this one. 3, 9, 27. This looks like we're 9 divided by 3, 27 divided by 9, 80. Yep, we've got a common ratio of 3 here, haven't we? So we've got geometric. The 10th term in the sequence. So what's U10 here? Okay, so it's U1, which is 3, times my ratio, which is 3, to the n minus 1, which is 9. 3 times 3 to the power of 9. Get a calculator out, and we type in 3 times 3 to the power of 9, and we hit enter, and we get 59,049. 59,049 is our result. And then it's a sum question, which we will come to in the next YouTube. I'll close it there. Have a look out for the next YouTube on finding sums of series and infinite sums.